Hello everyone, let me introduce myself. I am Facundo Carballo and today I will explain you one of the main concurrency issues that we have when we apply concurrency, that is race conditions. Before we start with the video, I want to tell you that all the code that you will see here, you will have it on my GitHub repo. The link to that GitHub repo will be on the description of the video. And well, one more thing. If you like this kind of videos, please hit the like button and subscribe to my channel because that will help me a lot. Race conditions are generated where multiple coroutines, multiple concurrent processes are accessing to the same resource at the same time. So for example here, like we see on the mutex example and also on the atomic example, the only goal of these two coroutines is read the value of this variable and then increment it by 1. But these two coroutines are working concurrently. So here, if we don't apply synchronization mechanisms properly, we can invoke a race conditions between these two coroutines. For example, in this timeline, you will see this easily because the coroutine number 1, in this case, executes first, and well, this coroutine starts to execute. The first thing that this coroutine do is, well, read the value of this variable. Once this coroutine reads the value of the variable, then the coroutine will have to increment the value by 1. But at this point, the operating system quit that coroutine and put the coroutine number 2 to execute. The coroutine number 2 start to executing, and well, the first thing that this coroutine do is read the value of this variable. And well, at this point, like this coroutine, this first coroutine doesn't increment the value of this variable, well, at this point, have 0 as value, have the same value that have here. So the coroutine number 2 reads the value of this variable on 0. Then, like this coroutine is still executing, this coroutine will increment the value of this variable by 1. So at this moment, if we read the value of this balance variable, we will see that the value of this variable is 1. Okay. But when this coroutine number 2 ends, comes again the coroutine number 1 to execute. But like this coroutine, the only thing that have to do is increment the value of this variable that this coroutine already read the value. So here, the coroutine number 1, the only thing that will do is increment the value of this variable from 0, because 0 is the value that this coroutine reads here, from 0 to 1, because this coroutine increment the value of this variable by 1. So we'll go from 0 to 1, instead of what we expect, that is, at this point, this variable has a value of 1. So here, when this other coroutine increment the value by 1, 2, we'll go from 1 to 2. That is what we expect. But like here, there is a race condition. In some cases, the results of our programs will be different from that we expect, although the code is correctly. So because of that, we have to implement synchronization mechanisms properly. So now I will show you an example of this race condition on code. So here we have two functions, a race condition function and a do work function. This race condition function, what it does is execute 10 coroutines, and all of those coroutines will do this do work function. This do work function, the only thing that does is increment this resource variable by 1. So if we execute here 10 coroutines and all of it wants to increment this resource variable by 1, at the end, when all of these coroutines ends, we expect that this resource variable have a value of 10, because there are 10 coroutines trying to increment this resource variable by 1. But we will see here, like, we are not applying any synchronization mechanism here to increment this resource variable, and this resource variable is accessing by a lot of coroutines in a concurrent way. We are provoking here race conditions. So it will be some cases where this resource variable will not be equal to 10. It's the same example that we see before on the mutex and the atomic implementation. But here, like we are explaining race conditions, I have to repeat this example because remind that mutex and atomic synchronization mechanisms are here to prevent these race conditions. So here this function, this race condition function, will execute this for end loop until gets a balance different from 10. When this function gets a value on this resource variable different from 10, we'll execute this part of the code and we'll finish because we'll break this for end loop. So to show you this, I will execute this function so you can see that it will be one case when this resource variable will have a value different from 10. And here is. We have it here, a balance of 9 when we expect a balance of 10. And well, that's all for this video. I hope that you could understand all about race conditions. And well, I will ask you again that if you like these kind of videos, please hit the like button and subscribe to my channel because that helps me a lot. So now, see you on the next video.